Hi, this is Owen Astrachan with Video F, ArrayLists for Compsci 201 academic year 2021-2022. This is Video F, and F is for folder, aka a directory, where you put the code that you're going to get using Git. F is also for function, which in some ways is an abstraction over code. We use the name of the function to represent the entirety of the code. In Java, we typically use the word method rather than function, but function is a name that's used in other languages. F is also for floating point, double in Java, that uses decimal points for precision, accuracy, and we need to be careful in some instances of overflow. F is also for front end. There is web development where you do front end on the web facing the user, back end that is processing what the user does, and full stack, which is both front end and back end. In this video, we're going to look at array lists, so I will review arrays briefly. As a reminder, they are an indexable homogeneous collection. Indexable means you use an integer to access individual elements with the bracket notation. The first index is 0, an array is fixed in size, and random access means getting the first element at index 0 takes the same amount of time as accessing the millionth element. Arrays cannot grow, so typically they're exactly filled with their contents. And we use the .length field to determine the number of elements, the size of the array. That lack of the ability to grow makes arrays useful for reading information, not so much for growing or extending. And so for that, we will use array lists. But arrays have other limitations. For example, you have to write your own loop to search an array. You have to write your own loop to find the first or last occurrence of an element in the array. In fact, arrays don't even print well. Here we can see that I've created an array of 4 string values, ant, bat, cat, dog. And when I try to print it by simply saying system.out.println A, I get something representing the array's location in memory. String at 5b2. That's not a useful representation, but there's an arrays class, and when I use that arrays class API by calling arrays.toString, passing array A to the toString method of the arrays class, I get back a string that is representative of the array contents. ToString is a static method, meaning we apply it to the class. We know arrays is a class because it begins with a capital letter. We'll explore more classes that are part of java.util, the package in which these occur. Why do we need java.util.ArrayList? Because they're like an array, homogeneous collections supporting random access, but they grow. And they also contain useful helper methods that are part of each array list object. We can ask if an array list contains a specific object, a string for example. We can clear it with one statement, list.clear. We can determine the index of a specific element, where it occurs in the array list. We could write our own code for doing this with an array, but with an array list, the code is already written and we can access it using the ArrayList API. Array lists don't have the nice syntax of the bracket notation. We'll need to use something else, a method to retrieve or to store the elements of an array list. So they have the benefit of growing and having these methods, but they don't have the easy syntax of a bracket, and we'll see we can't store anything in an array list as we can in an array. Here, for example, is a simple use of the array list class. So I've imported the class, and whenever you're using something not in the java.lang package, which is where string is, you need to import it. If you look carefully at the code where we used scanner, we needed to import the class scanner from the package java.util. A package is a collection of related classes. Java.util stores mostly things like ArrayList or arrays, but also scanner, useful utilities that are used in many Java programs. Once we've imported it, we can then use an array list, and the syntax here is we specify the type of element stored in the array list on the left-hand side of the assignment statement, where we see array list angle bracket string, but we don't specify the type on the right-hand side, where we see new array list and then empty angle brackets, and then the parentheses indicating we're calling an array list constructor. We can then add elements to the array list, and we could call add hundreds or thousands of times. The array list will grow to accommodate all of those. We can determine the size of the array list as we see above here with a.size. That's a method we can tell from the parentheses, and it reports the number of elements in the array list. In this code, that would be 0 because it's printed before the add calls. Then I can use a for each loop, the same syntax that we've seen in other examples with an array, for example, for parentheses string, that's the type stored in the collection A, S is the variable, colon, collection A, and then we can print all the contents of the array list, which in this case would be hello world. We can also use an indexing loop. The difference in an indexing loop is we need to retrieve the elements from the array list, and we'll see that requires the use of a method named get. So like we saw before, we import the class from the java.util package. We create an array list object by including the type on the left-hand side and not on the right-hand side. We then add elements to the array list, and then we loop using a standard indexing loop. Start the index at 0. We could use any variable, but I like to use k. While k is less than a.size, we can see that's a method because of the parentheses. And then we print using the .get method. We can't use the simple syntax of brackets as we used with an array. And we see this get method retrieves values from the array list. Now that we've seen that, we'll just review a little bit that when you have a type array list, you must specify the type in angle brackets on the left-hand side of the assignment statement. You don't specify the type on the right-hand side. You use empty angle brackets because the Java compiler can infer the type from the declaration of array list string on the left. So in my code, when I see array list angle bracket string angle bracket A, when the compiler sees the right-hand side, it can determine that it's a string because of the left-hand side. And when that determination is possible, we don't need to include the type between the brackets for what's called a generic container. An array list is generic because it can contain any class, string, person201, or object. So the array list can store those types, string, object, or person201. However, it cannot store primitive types. And that's a little bit of a hindrance for use of array lists. So it can't store int, double, and boolean, but it can store what are called wrapper classes. Each of the primitives has a wrapper class that encapsulates the primitive type. So for int, that's integer. For char, that's character. And for double and boolean, the classes have the same names but with a capital letter because they're classes. So capital D double, capital B boolean. When we add elements to an array list, wrapping can occur automatically, and that's called auto-boxing. And you can unbox too, as we'll see. So in this code, I have created an array of 5 elements, 10, 20, 30, 40, 50. And now I'm going to add these one at a time to an array list. So I've created an array list of integer objects. I can't use int because array lists only store objects that are instances of a class. Int is a primitive, not a class. So I create the array list and then I loop over the array with primitive types. We can see in the for each loop int I, and I add those to list using list.add. Now the parameter here I is an int, but the array list stores integers. The I is automatically boxed or converted or used to create an integer object. That works fine for int to integer. And we'll see that it's possible to do some other kind of more mass conversions using a helper method from the arrays class. So if I create, for example, a string array containing ant, bat, yak, and zoo, I can create a new array list by saying new array list and then giving the entire array as a parameter. Unfortunately, the ArrayList class has a constructor that takes a list as a parameter, but not an array as a parameter. So luckily, I can convert the array of strings, A, into an array list of strings by calling arrays.asListA. And then when I print, as we've seen, printing A results in the memory location because it is an array. But printing the array list, named list here, results in an actual semantic representation of the contents of the array list. That works great for strings. Array of strings, convert to array list of strings. It doesn't work so well with primitive types. So in this code, for example, I try to do the same thing by saying I have an array of 4 int values, and then I try to use my same arrays.asList method to take that array and turn it into an array list. Unfortunately, Java generates an error, cannot infer type arguments, and it goes on and on. And that's because you can turn one int into an integer with autoboxing, but arrays.asList cannot convert all of that array of ints into an array list of integers. That might have been possible for the Java class designers, but they chose not to do it. We have seen in other contexts arrays.asList used to construct an array list. I can also use arrays.asList to construct a hash set. Both of the ArrayList class and the hash set class have a constructor that takes a list as a parameter. Both those classes also have a handy .addAll method. .add always adds one element. .addAll adds all the elements in here from a list, as it turned out from other collections, into X, where X could be an array list or a set. That's a brief introduction to the ArrayList class. And now I'm going to set up the next video by talking about some performance trade-offs and the ArrayList class with algorithms to demonstrate these. I'm going to use the problem of reading all the words from a text file. I'm going to see how we store those in an array list, and they'll be in the same order they occur in the file. There might be many duplicates. I'm going to look at 4 algorithms that take that entire list of all the strings in a file and create a list of unique words in sorted order. So we can see here, if I'm all of a sudden processing dog, I will have to add it between ant and fun to keep the list ant, fun, hug, pup, wow in sorted order. I'm going to have 4 algorithms that take a long list with duplicates and, using different algorithms, create an array list that's sorted of the unique words. We can see this code in ArrayListUnique.java. I've given the URL for the Git repository, but we're going to reason about these next time. I'm going to look preliminarily here to set the stage for that. This reasoning about efficiency is one of the cornerstones of Compsci 201 and the study of data structures and algorithms. We're going to use engineering, science, and math. We will build programs, perform experiments by running those programs with different inputs. We will analyze those results by looking at them, perhaps graphing them. We will evaluate those results. That's the engineering part. We'll also use some math and science to reason theoretically about these. So this theory and practice will be combined in our study of these different algorithms. These trade-offs are one of the cornerstones of Compsci 201. Here's the code that is going to read everything from the text file into the array list. I'm going to create a scanner named S from a file. In this case, we see here that it's Hawthorne's A Scarlet Letter, but I can use any file. So I create a new file, I create a scanner from that file, and I assign a reference to that to S. Then I create an empty array list, and I simply loop over all the words using a scanner. We've seen this before, well, s.hasNext, and then I call s.next to get all the words in order, and I add them to the array list. But in adding them, I'm going to convert them to lowercase. And we can see I can do that in one statement, essentially. I can say s.next, that's the next thing in the scanner, which is a string, dot to lowercase. That returns a string. That's the lowercase version of that s.next. I time this, and then I'll evaluate the results. 3 different methods, actually 4 that we'll see, will take the list of all the strings and then create a sorted list of unique strings named ret. In looking at these algorithms, I will leverage the idea that ret is sorted, and I will add strings one at a time to the list being built. We will see that different files exhibit different runtime characteristics. These are the times from my laptop that I ran recently, and we can see that when we run Hawthorne's A Scarlet Letter, it takes 0.155 seconds to read all of the 85,000 words in A Scarlet Letter, and then these different algorithms for returning the list of sorted unique words, well, one algorithm, A, takes much longer than the other algorithms. We'll see why that's the case when we study these other algorithms. When we look at Darwin's Origin of Species, which has almost twice as many words at 160,000, we see that does take longer to read, and then algorithm A, which was the slowest, is still the slowest, and the other algorithms are faster. And we'll study why they're faster and use that to understand the trade-offs in different algorithms. Before we go there, though, I want to look at Joe Buolamwini, who is the founder of the Algorithmic Justice League. This is a group of scientists and policymakers that strive to ensure that algorithms are fair and free from bias. Algorithmic Justice League is a great name. Joy Buolamwini was a Rhodes Scholar, an Anita Borg Scholar. She has a great TEDx talk on fighting algorithmic bias. In particular, she started with facial recognition bias, but that's now been expanded to many different algorithms, especially in the area of machine learning and artificial intelligence. And she says, in exploring this facial recognition, I could have viewed my face not being consistently detected as, oh, that's a technical challenge. But being in the space of the Center for Civic Media at MIT definitely orients me to say, this is not just a technical challenge. This is as much a reflection of society as other spaces where you see inequities that need to be addressed. We will be exploring some of these inequities in our study of algorithms and data structures in Compsci 201. I hope you will join me in trying to ensure that our algorithms and our work are free from bias and are fair. We can admire the work of Joy Buolamwini as we embark on our own programming. Enjoy.